Hey, good morning, good afternoon, and good evening, everyone, depending on where you're joining us for today. So, how are you, Håkan?
Yeah, I'm really good, and I'm really excited about this session for tonight, where we'll talk about data analytics with Python.
That sounds interesting. Would you like to tell a bit more about the session before we get started?
Yes, so what we will learn today is we will learn about the basics about Python and the different libraries that we can use to do data analytics in the first half, and then in the second half we'll actually use the COVID-19 dataset, and then we will do some analysis of that dataset using these libraries. What we should also say that our guest, Wei-Meng Lee, unfortunately due to some time differences, he couldn't be with us live here on the stream, but instead we have a recorded version of his talk that we will stream, and then you will be able to ask questions, and we'll try to answer them as best as we can. And if there are some questions that we were not able to answer, we'll just forward them to Wei-Meng, so you will have the answers.
Yes, and don't worry about feel free to ask your questions, post them in the chat, and we are going to be here to help you out if you have any questions. I think it's time to get AI42 to be introduced.
Yes, we will do that. Yes, there's one more thing here. We will also post a link in the chat to our GitHub repository, because there on that you have some instructions on how you can download and install the Anaconda, so that you can run this notebook that Wei-Meng will use, so that you can follow with him during his session. But
cool.
Let's go over to the AI42 presentation.
Welcome back, everyone. We all know it is quite hard to find the right materials on the internet to learn about data science and machine learning in a constructive way. So the motivation for starting AI42 comes from this recognition, so that there is no really good starting material, and we aim to take you all the way from complete beginner to getting enough knowledge to be able to build your own model. Håkan, would you like to tell a bit about our concept? How do we do this?
Yeah, so the way that we have done this is that we have invited industry experts and recognized speakers. So they will be with us in this stream. So we're streaming 2 times a month on Wednesdays at 5 o'clock Central European time. And by doing this, we will cover the material all the way from the ground, from the basic mathematics, and then probability theory and statistics, over to languages such as Python and R, and also tools like how you can use Power BI or Databricks, and also, for example, how you can set up your own machine learning pipeline. And we also have some more advanced topics like reinforcement learning and explainable AI. And in addition to these more theoretical lectures, we will also have some workshops where you can put this theory into practice.
And the cool thing about joining us is also that you'll be able to connect with the best-in-class experts from all around the world that will hold you these lectures and workshops with really rich content. And you can also meet different people and extend your network in the field of AI and data science. You can follow us on Instagram, Twitter, and Facebook, and you can find our recordings on YouTube. And if you want to hear about our coming up sessions, you can go to our meetup page.
Yes, and we would like to thank our sponsors. So we're sponsored both by Microsoft and we're sponsored by Miles. So thank you so much for that.
And we also would like to say a great thank you for all our supporters, Global AI Community, C# Corner, who are also hosting our sessions on their channels. And thank you, Mina Marie, for the awesome music that you can hear during our streams as well. And thank you, Levente Pongo, for the great graphics that we are using for our streams and the speaker cards and so on.
Yes, so then I think we'll just return the presentation here to Wei Meng.
Hi, thank you for attending my session. My name is Wei Meng, and I am the founder of my own training company, Developer Learning Solutions. And in the next hour, 1 hour or so, I'm going to go through with you on how to use Python for data analytics. As some of you are already very familiar, Python is one of the most popular programming languages out there in the industry. And for the past 5 or 6 years, Python has been getting really popular. Part of the reasons is because there are some really fantastic third-party libraries, Numpy and Pandas, which makes analyzing your data really simple. And also there are this wonderful third-party plotting libraries like matplotlib that makes it really easy to actually plot very nice graphics. So in the next 15 minutes or 1 hour, I am going to go through with you some of the basics, and I am also going to show you a particular case study. In particular, we will make use of the COVID-19 dataset, and we will make use of Python, Numpy, Pandas, as well as matplotlib to analyze the COVID-19 dataset. So let's get started. So first thing, what is the agenda for this talk? So I'm going to give you an introduction to data analytics, what are the things involved in that, and we will also talk about some of the scientific libraries in Python. In particular, we'll talk about Numpy, Pandas, matplotlib. And last but not least, as I mentioned, we will analyze the COVID-19 dataset using all these libraries. So first thing first, what is data analytics? So data analytics is basically the science of examining raw data to draw conclusions about that information. Now, today, companies are collecting tons and tons of data, but companies are not able to fully understand how to use all this data for analysis. So this is where analytics is useful, and it allows you to use all the various tools available to draw some interesting conclusions or maybe make predictions based on the data that you have collected. Now, so typically in a data analytics project, here are the following steps. So first of all, you have to get the data. And today, this is not really a big problem because companies, like I said, are having too much data, but they do not know what to do with the data. And once you got the data, you got to clean the data. So you got to clean the data, format it into a way that you want to use and be able to use them. And that is the next step. You have to wrangle the data into a format that is suitable for your own use. And of course, after you have wrangled the data, you want to be able to analyze the data. And after analyzing the data, the best way to actually look at the data is to actually visualize them, see what is the trend, and maybe there are some gems that you can actually derive out of this set of data. So that is basically the steps for data analytics. Now, of course, beyond data analytics, you can make use of the data that you have actually cleaned and wrangled, and you can actually perform machine learning. You can also go one step further and perform deep learning. So, but that is the beyond the scope of this talk. So for this talk, we are going to focus just on data analytics. Now, I always like this quote. So without data, you are just another person with an opinion. Okay, so data is really important, and the ability to actually derive meaning out of your data is even more important. Now, so why Python for data analytics? So first of all, let's address this question. Why Python? So as I mentioned earlier, Python is one of the most widely used programming languages out there in the world. So chances are you already know how to use Python. You are very familiar with this language. And today, Python is usually taught as a beginning programming language to students. So in Singapore, a lot of schools are starting to teach Python as a first language to students. So traditionally, schools have been using languages like maybe C#, Java as a first language, but increasingly, a lot of schools are switching over to Python. So why is Python so useful, so easy? Because the syntax of Python is actually very clear, very English-like, and it forces the coder to actually indent the code, and that makes your code much more readable. And for this reason, a lot of schools are using that, and there is an active communities of libraries and modules for Python. So today, if you use the Python programming language, chances are, if you want to perform a specific task, chances are there is a library out there, there is a module out there that is able to do what you want to do. So, and for this reason, Python is actually very, very popular. Now, when it comes to using Python, there are many tools available for you to actually write your Python code. So personally, my favorite is Anaconda. So what is Anaconda? So Anaconda is basically an easy to use free package manager, environment manager, as well as a collection of Python libraries that allows you to write your Python code without needing to install additional libraries, and it all comes with a single package. And Anaconda supports Windows, Linux, as well as Mac OS. And it ships with a very interesting feature known as Jupyter Notebook. Jupyter Notebook allows you to break down your complex tasks into smaller chunks of code, and you can put your code in individual cells, and you are free to execute each individual cell independent of the other blocks of code in your Jupyter Notebook. So that makes it a very, very useful tool for data analytics. Why? Because typically in a data analytics project, you have a few steps. Like I mentioned earlier, you have the importing of the data, you have your data cleansing, you have your data visualization, you have your data analytics. So you can put all this block of code into your Jupyter Notebook, run them independently, and at the same time, you'll be able to write descriptions within your Jupyter Notebook and then share your Jupyter Notebook with your fellow co-workers. So for this reason, I'm going to use Anaconda in this talk. And later on in the demo, I'm going to make use of Anaconda and Jupyter Notebook to show you how we can actually work on our data analytics project. Now, Python. Now, there is one fundamental data structure in Python, which is very, very important for storing collection of items, and that is the Python list. Now, the Python list data structure is a very flexible data structure. So it's like an array in other programming languages, except that unlike arrays in other programming languages, it allows you to store items of varying data types. So in a typical Python list, you can store values of type integer, floating point, strings, booleans, so on and so forth. And because of this flexibility, there is a cost associated with it. Now, because of the way the Python list is implemented, because internally they have to be prepared to be able to store items to be of varying data types. So it is very costly and very inefficient when it comes to accessing items in a Python list, especially if the list is huge. And in the field of data science, usually the data that we are involved in, they are of uniform data type. Okay, so because of that, a Python list is not very suitable for doing data analytics projects. Now, in order to overcome this limitation, you need to make use of a third-party library called Numpy, or numerical Python. Now, Numpy is an extension to the Python programming language, and it adds support for large multi-dimensional arrays and matrices, along with a large library of high-level mathematical functions to operate on these arrays. So in short, you use Numpy to store a collection of items or of the uniform data type. So unlike lists where you can have mixed data type, in a Numpy array, all the items must be of the same data type. So, and because of this, Numpy, in terms of efficiency, it's much faster and much more efficient compared to Python. And part of Numpy is actually implemented using C, a collection of C and Python code. Now, so like I mentioned, in Numpy, an array is of type ndarray, and they are all of the same type. So consider this example where I have a list L1, 1, 2, 3, 4, 5, and I can convert this into a Numpy array. So np.array, I can convert this list into an array, and once I have converted this into an array, I can print out the shape. Now, Numpy arrays can be single dimensional, multi-dimensional, 2D, 3D, 4D, as many dimensional as you need. And the nice things about this is that it works just like a list. You can access each individual element using its indices, or you can perform slicing on a Numpy array. Now, so the conclusion is an ND array, it's much more efficient than the Python's list, and it also provides functions that operate on an entire array at once. So let's take a look at one example. So let's talk about this topic called Boolean array indexing. So consider the following array. So I have an array of the following elements, 23, 45, 78, so on and so forth. And so the typical question is, how do you retrieve all the even numbers in the array? So now, if you come from the traditional programming camp, like C#, Java, or whatever, or C, what you would typically do is maybe we write a loop, and for each item in the loop, we check the value. If the value is an even number, we get the value out, or we append it to another list. But using Numpy, things are actually much more straightforward. So you can just simply specify your condition. So in this case, my nums is my Numpy array, and I specify my condition nums modulo 2 equal to 0. So the end result is whatever even numbers I have in my nums array, it would be returned back to me. Now, what happens if I want to say retrieve all the numbers greater than specific values? So again, using Numpy, you can just specify your condition. So nums greater than 5, that's it. And it will print out all the numbers greater than 5 in this example. Okay, so that is Boolean array indexing. Now, so we have talked about the Numpy library. So the Numpy library allows items to be stored in an array, all of the same type. Now, the next important library that we need to make use of is called the Pandas library. So most of the data that we encounter today, they are in tabular format. Think of them as your Excel spreadsheet. So instead of representing all these numbers in arrays, wouldn't it be much more efficient if we can have a way to represent all this tabular data in a convenient data structure? And this is where Pandas comes in. So Pandas allows you to actually implement your data set in a tabular format. Now, behind the scene, Pandas make use of Numpy arrays to implement and save all your data in the tabular format. So Pandas allows you to represent your numerical data in tables format, and usually your data may come from a wide variety of sources like your CSV files, your databases, your Excel spreadsheet, or whatever data source that you can imagine. So because of this, you should use Pandas, and Pandas stands for Panel Data Analysis. So it is a software library written for Python for data manipulation and analysis. So if you are in the data analytics world, Pandas is going to be your good friend. Okay. Now, so here is one example of a Pandas data frame. So let's take a look at the code. So imagine that I have the following code. So I created a list of random numbers. I'm going to create a list of random numbers, 10 rows by 4 columns. And all these numbers are normally distributed. Okay, so I am going to create 10 rows, 4 columns of normally distributed numbers. And I am going to pass it into a pd.dataframe class. And the columns are specified as A, B, C, D, respectively. So when I print out my data frame, it looks like this. So in this example, I have 10 rows and I have 4 columns. And typically, this is how your data looks like when you are accessing them in another platform. Like, for example, you have your data in Excel or in CSV format. And using the data frame, you can slice and dice your data frame. So for example, if I want to retrieve row number 1 to 5, so I can simply do an ilog 1:5. So 0, 1, 2, 3, 4. Okay. And if I want to slice the columns, I want to extract a specific column, I can do an ilog. And then I say that I want to select all the rows, but after the comma, I want to specify all the specific columns that I want to extract. So you can slice rows, you can slice columns. Now you can also slice rows and columns at the same time. So I can slice row number 1 to 5 and column 2:4, 2 to 4. Okay, so I can slice either way, rows, columns, or both rows and columns. So that is a very basic introduction to Pandas. I know in this very short presentation, it is very difficult for you or for me to explain to you the entire library, NumPy and Pandas, but hopefully that gives you an idea of what you can do with NumPy and Pandas. And I'll leave it to you to go and explore further on how to make use of these two libraries. These two libraries are really huge. And if you go to stackoverflow.com, you would have the chance to see a lot of questions being asked regarding NumPy and Pandas. So it takes more than just one session to actually understand how to make use of them. Now, the next thing that is important to us is data visualization. After you have analyzed your data, after you have cleaned the data, imported the data, cleaned the data, wrangled your data, you want to be able to visualize them. And so this is where visualization is important. So as the saying goes, a picture is worth 1,000 words. So in Python, there are many data visualization tools available that allows you to actually convert your data from raw format into a nice little picture to explain to you the trend of your data. Now, so for this particular talk, I'm going to mention just this particular library called matplotlib. So matplotlib is a Python 2D plotting library which produces publication quality figures. So not only 2D, you can actually use matplotlib to actually plot 3-dimensional charts. So that is also possible. And a number of Python libraries like Numpy and Pandas, they have built-in support for that. So you can directly plot from within your Numpy array or your Pandas data frame. So here's one very simple example. So here is a simple line chart. So in order to create this line chart, you just need a couple of lines. So you basically just need to import the matplotlib library and call the plot function to plot a line chart and specify the values in the x-axis and specify the values in the y-axis. And that's it. When you run it, the chart is plotted. Of course, you are not limited to plotting line charts. You can plot pie charts, bar charts, scatter plots, whatever you can think of, you can do that. Now, in addition to the matplotlib library, you can also use some other libraries like Seaborn. Seaborn is another plotting library that is very popular, that is based on the matplotlib library. So it's acting like a wrapper around matplotlib. So using Seaborn, you can create very compelling graphics with just a few lines of code. So underlying Seaborn, they actually make use of matplotlib to actually generate all the very nice charts. So when you have the time, please go and check out matplotlib as well as Seaborn. Okay, so we have been talking about Python, Numpy, and Pandas. So I think it is time for us to actually look at one data analytics projects that everybody can do, and what is more interesting than the COVID-19 dataset. So today, a lot of countries are battling the COVID-19. So I think this is a good time for us to look at a sample dataset so that we can learn how we can actually look at a dataset and use whatever we know, Python, Numpy, Pandas, to derive some meanings from this set of data. So for this particular example, I am basically using the dataset available from Kaggle. So if you are interested, please go ahead and download the dataset. And there are two particular CSV files in the dataset that I'm going to use. And it is called time series COVID-19 confirm.csv and time series COVID-19 dev.csv. Now, towards the end of this presentation, I will make the Jupyter notebook that I have used for this demonstration available so that everybody can download that. So because there are quite a number of things that I'm going to do in the Jupyter notebook, so I may not be able to explain all parts of the code, but if you are interested, please go ahead and download the Jupyter notebook so that you can test it for yourself. Okay, so I'm going to switch over to the demo and see you soon. Okay, so let's start with the project on the COVID-19 dataset. So as you can see from my Jupyter notebook here, I have already downloaded the dataset and I have saved the dataset into a folder called dataset 03 April 2021. And so the first thing that I do here is that I am going to import the two libraries, Pandas and Numpy. And once I have imported the two libraries, I am able to now go ahead and import the CSV files. So there are two CSV files that I'm using. The first one is the confirm.csv and the second one is the dev.csv. Now, the confirm CSV data file contains all the confirmed cases for each country over a period of 1 year or so. So the dev dataset, on the other hand, confirms or rather stores the number of deaths for each country over a period of 1 year or so. So once I have loaded them up using my Pandas library, I want to print out their shape. So that is the first thing that I do. So I have the shape 274 by 407. So 274 rows, 407 columns. Now, and usually the first thing that I do is after I have loaded up my data set, I would want to take a look at the data set and see how it looks like. So as you can see from here, there are 274 rows and 407 columns. Now take note that the dates are stored horizontally as columns. So for example, last year, January 22nd, you have one column, and 23rd January, you have another column. So this is how the data is being stored in by the respective party. So, and also take note that for each country, I also have a province or state. And I also have the latitude and longitude for that particular state or province. And so what I want to do next after importing the data frame is that I want to sort the values. I want to sort them by province, state, as well as country. So this is what I do. And after sorting, you will see that this is my sorted data frame. So I have Alberta, Canada, and followed by all the values here, and then so on and so forth. Now, next thing, I also want to sort the data frame for the data set on the def cases. So I want to sort them. And so this is how it looks like. So at this moment, I have two data frames. And I want to sort them by province, state, and country. And one of them is the confirm cases. The other one is the def cases. Okay, so that is my two data frames at this moment. Now, next thing, it will be useful for me to compare these two data frames to make sure that these two data frames, they are containing the same province, state, as well as country region. Okay, so in this case, I take these two data frames, retrieve the two columns, and I compare them, and the result is true, so they are the same. Okay, now next thing, what we want to do here is that we want to extract the dates. If you look at the data frame here, it starts here. These are the dates. So 0, 1, 2, 3, 4. So index 4 onwards, I want to extract all the dates. So this is what I do. I specify the dates for my confirm cases, the dates for the def cases. And after that, I want to print out the values. And I just want to make sure that the dates are all the same. So because I'm getting from two data frames, it is important for me to compare them and say, okay, this two set of dates, they are the same dates. It is very likely that when you get data from somewhere, these two data frames, the dates may not tally. So you have to be careful about that. Now, so now that I know that these two set of dates are identical, so I can move on to the next step. Now, recall that I mentioned that the dates are stored horizontally. So when it comes to manipulating data of this format, it is always not so effective, not so easy to deal with. So a better way would be to unpivot this data so that we have a separate column representing the date and another column representing the values. So, and this is what we are going to do next. We are going to use the melt function. So I am going to unpivot this data frame so that after unpivoting them, my dates are now stored in a separate column, and I have a new column called confirm to store the numbers of confirmed cases. Okay, so and I do that for the df-def data frame as well. So let's do a quick check. So after unpivoting my data frame, my df confirm melted data frame looks like this. So now I have 110,000 rows. Okay, and I have the following columns: 1, 2, 3, 4, 5, 6. Likewise, for the def melted data frame, it looks like this. So you have a new column called date, and you have a new column called def, which records the number of def reported for each country as well as region. Okay, now, so let's now print out the shape of these two data frames to make sure that they are the same. Okay, and so these two data frames, they have the same shape. And what we want to do now is that we want to be able to combine these two data frames into a single data frame so that it is easier for us to manipulate this data frame. So what we can do now is we can use the pd.concat function. We want to concatenate the def column of the def melted data frame with the def confirm melted data frame. And so after combining them, I should get a single data frame. So in this example here, I only have a single data frame, but I have these three columns here: date, confirmed, and def. Now, what we are going to do later on is that we are going to make use of all these numbers, and for each country, we are going to plot the total number of confirmed cases as well as the number of def for a particular date. Now, so the next part here would be to replace all the NANs inside the data frame with zeros, because there are some cases where there are no values, some columns with no values. We want to be able to replace them with zero. So we will use the fillNA function. And so my data frame now is getting cleansed. Now, next thing, look at the date format. The date format. So the date format here is in the string format. So what I want to do next is I want to be able to convert this date from the string format. I want to be able to convert this into the date time format. Now, specifically, I have written a function here called format time, which takes in a string and allows me to convert this into a date time format. And in this example, after converting this into a date time format, I want to return the date component. So essentially, I am converting the string format into a datetime.date format. Now, because in this case, all the dates for the cases, they do not include the time. So in this case, we just need the date component. So again, let's try to recall the items that we have. So string format. And so now I am going to apply this function to this date column. And after applying that, this is my end result. So I have a date column, which is of, in this case, it's object format, but I have formatted this to become a datetime.date object. Okay, now, so now that our data frame is more or less cleaned, we want to do some interesting things. So first thing first, we want to use the group by function. We want to use the group by function, and we want to group by the date. So I use a df combine.group by. I group by the date, and then for each day, I want to print out the following information: the province, state, the country, region, and number of confirmed and def cases. So if you look at the output here, my output starts on the 22nd of January last year, 2020. And for each day, I print out the total number of cases for each province, state, and each country and region. And then when I scroll down, I'll see the figures for the next day. and all the way to the last day, which is 27th of February 2021 this year. Next thing. So now that we are able to print this, we want to apply what we call aggregate functions. So we want to be able to look at our data frame and say that, okay, can we get the total daily numbers of confirm and def for each country? So regardless of the province or state, we want to group them by country. So I use this data frame df combine dot group by, and I want to group them by date as well as country or region. And once I've done that, I want to apply this aggregate function, and I want to sum some columns up. So I want to sum up the columns called confirmed, and I want to apply this sum function to sum up all the values. Likewise, I want to sum up all the values in the def column. So the end result would look like this. So for each day, what are the total number of values for each country? So in this case, we are grouping by country. So if you go look at the numbers in the 27th of February, you have all these numbers. Now, if you are interested in getting just a specific day, the numbers for a specific day, you can use the df daily, which is this particular data frame, and pass in a date that you want. So for example, I want to get the numbers for 27th February 2021. I just need to pass in this value, 2/2721. And this format time is the function that we have written and I have explained earlier. And you should get the following value. So if you want to get the value for 26, you can change this to 26, and then you can just run it, and you should be able to get this value. Okay, next thing. What happens if you want to get the values for a specific day for a specific country? Now, in this case, you could also use the df daily data frame, specify the time as well as the country, and wrap this up as a tuple. And so in this case, if you want to know the numbers for US on the 27th of February, you can specify this, and you should get a value like this. Okay. Now, so what happens if you want to get the data for the most recent day? So what we can do is we can get this data frame, get the date column, and find the maximum value. And the maximum value, the most recent date, is actually 2021, February 27th. And so in this case, I want to extract the latest date. So this is the data for the most recent date. Now, next thing. What happens if I want to know which are the top 10 countries with the confirmed cases? So I can make use of the df most recent data frame, and I can sort it by the date, sort it by the column, confirmed column, and I want to sort it in descending order. So I want to sort those with the biggest number first, followed by those with the smaller numbers. So once I have sorted this, I can extract the first 10 rows, and this is the result. Next, how about the top 10 countries with the most def reported? So in this case, I take the df most recent data frame, and I sort by the def column in descending order. And because there there might be countries with no death reported. So I only want to select those with death more than 0 and then get the top 10 rows. And this is what I get. So as you can see, okay, in both cases, the US is number 1, okay, both in confirmed cases as well as in the number of deaths. So in the case of confirmed cases, the second after US is actually India. But in terms of number of deaths, Brazil comes in a second. Okay. Now, so all these values are useful for us to know how is how are the various countries progressing. The next part that we want to do is that we want to be able to visualize. We want to visualize the number of confirmed cases and death for each country. So rather than see all these numbers, it would be more interesting and more useful to be able to visualize the trend of each country. So in this example here, what I want to do is that I want to plot for each country the number of confirmed cases as well as the number of reported deaths. So as you can see from this output here, so this is the number of cases for Afghanistan. So if you look at this, so the red part here represents the number of deaths. So if you scroll through, you will see the next country, Albania, and you can scroll through and you should be able to see whether you can find a country that you would like to know more. And then like in the case of US, so the cases are climbing quite steadily for the past few months. And then I think it is having a little bit of slowdown. Okay, now, so this is useful in visualizing the number of cases for each country. Now, how about plotting this as a pie chart? So we want to be able to know, so what is the proportion of the cases for each country, the top 10 countries, for example. So in this example here, I am going to plot the top 10 confirmed countries using a donut chart, which is a kind of pie chart. So if you visualize this, you will be able to see that, okay, for the top 10 confirmed cases, US is number 1, followed by India, followed by Brazil, followed by Russia, United Kingdom, so on and so forth. And if you want to visualize the top 10 countries with death reported, then you will be able to see that, okay, so for US, again, US is number 1, followed by Brazil, Mexico, India, so on and so forth. Okay, now, the next thing is interesting. Now, if you recall the charts that we have generated earlier on, all these charts, it is a little bit difficult for us to see whether the situation in each country is improving. Why is that so? The reason is because the data that we have is cumulative. So the numbers that we have each day is the numbers that was reported for the day plus the numbers that was available yesterday. So every day you keep on piling up the data. You keep on summing up. It's a cumulative sum. So when you have a cumulative sum, it's sometimes a little bit difficult for you to really know whether the situation in a country is getting better or worse. So a good way is for us to know. So we want to be able to unroll the data. So that means I want to reverse the cumulative sums. So I want to be able to convert from the cumulative sums to another column where I can know the exact number for each day. And based on that, I'll be able to know whether the situation is improving or is getting worse for that country. So And that's what people are always saying. They want to know whether that particular country is flattening the curve. That means you are trying to reduce the height of the curve so that it's getting flatter. Now, so this is what I'm going to do. In particular, I am going to use this diff function. So this diff function basically allows you to specify this particular data frame or a specific column, and it allows you to actually compare this value with the previous value. And by doing that, you'll be able to reverse the cumulative sum. So that instead of having the total number of cases up to that point, each day you have a specific number. Now, once I have done that, I am going to plot a series of line charts for each country. And so now the situation here is much, much clearer. So if you look at this, you look at Afghanistan. Initially, it was spiking, and then it becomes better. And then somehow, for some reason, in the January of this year, the figures just jump up. So likewise, if you take a look at countries like, for example, the US, let's see whether we can jump to the part on US. There you go. Okay, so US seems to be pretty bad last year, and then earlier on this year, there was a spike, and then now for the recent few months, I think it is slowing down. It's going down, so it's getting better. So by reversing the cumulative sum, we are able to actually see whether a country is flattening the curve or not. Okay, so this is much more useful. Now, last but not least, we want to be able to display all the confirmed cases on the world map. So because this is a world event, we want to be able to know which country is the most severely affected by the pandemic. So we can actually use our data frame, grab hold of the data, and plot it on a world map. So to do that, we can make use of Folium. So Folium is a powerful Python library that allows you to create world maps, and it is based on the OpenStreetMap. So to install Folium, just do a pip install Folium. And in this example here, I'm trying to extract the most recent date, the numbers for the most recent date, which is in this case 27 February 2021. And then I will create a map. And for each country, I will plot two circles. The first circle is the number of confirmed cases, and the second circle is the number of deaths. So for the confirmed cases, I will plot using green in green color, and I will plot it on the scale. So depending on the numbers, the radius, it's dependent on the number of cases. So the more number of confirmed cases you have, the wider, the bigger the radius. Okay, so let's so the radius is here for the confirmed cases, and the radius is here for the deaths. Okay, now so once I run this, a HTML file would be created called COVID-19 map.html, and it will be available in the same path as your Jupyter Notebook. And so when you look at the file, you will see something like this. And the green color circles represents all the confirmed cases, and the bigger the radius, the bigger the circle, the more number of confirmed cases there are. And the red dots here represents the number of deaths. So you can actually zoom in or zoom out. Okay. And okay, so this is US, this is India, and so on and so forth. Okay, so hopefully this very simple exercise has given you some motivation to investigate the various libraries in more detail, more specifically Numpy, Pandas, as well as matplotlib. So like I mentioned earlier, I will make this source code available. And if you have any comments, please go ahead and send me an email, and I will make my email available. And thank you very much for tuning in. Have a nice day. Bye bye.
Hi, and welcome back again, everyone. First of all, I want to say a big thank you for the session, Wiming. And I hope you all enjoyed it a lot. And I think it is time to take the questions, Håkan.
Yes. So
as we said in the beginning, we are going to try to answer your questions. And if we cannot answer some of your questions, we will forward it.
Yeah, so the first question is from Steven. He says, with so many EDA tools available, which one is your favorite?
I think it sort of depends on what you're using it for. But like, I don't know if you heard about this SweetWiz, which is really nice for amazing visualizations, and it also automates EDA, and it can be used for comparing data sets and drawing inferences from it. Or maybe you want to try out AutoWiz, which is also an open source library, and it is focusing on visualizing the relationship in the data. And it makes you available to make awesome and creative visualizations with only one line of code, which is really nice. Thank you for the question. So let's see, what is the next question? Let me see.
Question. I just posted the links here to SweetWiz and to AutoWiz.
Thank you.
Here's the next.
Yeah, that's the next one. Okay, so what are the advantages of choosing Python or R over SSBI tools like W or Power BI for data analysis of visualization? As Power BI is quite easier and we can make amazing dashboards as well. Håkan, would you like to take that?
Yeah, so I would say that even though tools like Tableau and Power BI is easier to use, there's always a cost, like it can be a license cost, and there's also a cost of actually learning how you can use these specific tools. So maybe even if you're an expert in Power BI, it's not directly translatable if you will start to use Tableau, for example. Whereas with Python and with the you put the notebook and the environment we have used today, that is completely free to use for anyone. And in addition, then you actually know what is going on under the hood. Whereas if you use maybe Power BI or Tableau, then it can be sometimes it can be a little bit too oversimplified so that you don't actually know what is happening.
Nice, thank you, Håkan. I think I have another question for you. Let me show you this one. Yes. Is it possible to somehow calculate the intersection of the graphs? Convergence points. Sorry, I can't talk anymore.
Yeah, that's actually, I think that is a question that we can forward to Wei Meng. But what I do know is that there is one library that you can use to see the intersection of data sets. So there's a matplotlib library called matplotlib Venn, where you can visualize Venn diagrams so you can see which numbers in different sets are actually common among the different sets here. But we will forward that question over to Wei Meng.
Thank you. I found something interesting as well. To become a data analyst and get a job easily, do you recommend to learn all the tools like Microsoft Power BI, W, and Python, or learning Python only is enough? Can I try it first?
Yes.
I think it also, I mean, to become a data analyst, that is also a very expanded thing, right? So you maybe want to focus on data cleaning, or you want to focus on visualization. Depending on your preference, you would go for a specific tool maybe. Other than that, it is useful to say that, for example, I am more on the Python side because I can do more with code than just I mean, with coding, you can also do the cleanup of the data, prepare the data set for whatever next steps like machine learning or whatever. And you can also make visualizations with all the awesome Python packages that are available for you, and also the other open source packages that are available. What do you think, Håkan? Do you have
I would say, there are different tools for different problems. So it's also depending on how complex your problem is, and of course, how much knowledge you actually have, and also some different time constraints. I think we can draw a similarity to what is happening now with the low code or no code tools such as Power Apps. So there's nothing is better. I mean, you can implement something from scratch, or you can use this low code solution. So it's just dependent on sort of your situation, how much you know, and your time constraints, and so on.
Yes. Thank you, Håkan. And I think we don't really have more questions. If I missed something, I'm sorry. We will take a look at it later again. And I think we can say thank you for joining us. And we really hope that you enjoyed yourself, and we provided you some new information. I mean, not us, but like Weiming. And we hope to meet you at our next session, which is going to be when exactly, Håkan?
Yes, our next session is in 2 weeks on the 21st of April. And in that session, you will meet Sine Sambak, who will teach us about how we can use R, the programming language R.
Yes, that's going to be really exciting. There is a bit of a battlefield between these two languages, so it will be nice to see you guys back and tell us your opinion, which language was, your preference. Like, which one was more interesting for you. So let's hope we meet next time as well. And thank you a lot for joining us. I wish you a great day or a great evening, wherever you are. So thank you again.
Yeah, see you next time.
See you.